Alright, I've actually just done this video and there's some problems saving, so I'm going to keep everything filled in and just talk you through this first page. We're going to be solving linear equations in 3 variables, not just one. So if you would highlight that, and recall that a linear equation with 2 variables, x and y, is defined as a line. Alright? If you have a linear equation with 2 variables, and if you look at this, it's still a linear equation. And the reason it's still a linear equation is each one of these is still to the first power. So we define linear equations by the exponents on the variables, and as long as it's one, it's considered a linear equation. All right. A linear equation in 3 variables has 3 distinct variables, each of which is either to the first power, or they're saying the only time one couldn't be, let's say I had a z to the second, is when it has a coefficient of 0, and the 0 would obviously take that z to the second out of it and make it a linear equation again. All right. Just as the 2 numbers that satisfy a linear equation in 2 variables called an ordered pair, x and y, 3 numbers that satisfy a linear equation in 3 variables is called an ordered. I'm going to call it a triple. You could say there is a pairing of 3 letters, 3 variables, and it would be okay to say pair as well. You're still pairing things. You're still placing them together. But we now have another variable, x, y, and z. All right. So all ordered pairs satisfying a linear equation in 2 variables that forms a line. All right. Likewise, if you have 3 variables, it's going to form a plane, and we're about to look at some examples down here. So when you look down here, let's just look this real quick. Any system, the specific number of variables must equal the number of equations in a system. So if I have 3 equations, there's 3 variables. All right. So when I come down here, they're saying, how many times do they touch? Well, obviously, right here, they don't touch at all, 0. And in the second one, we see planes 1 and 2 and 3. Well, we can see 2 and 3 both go through 1, but they never actually touch each other, so 0 times as well. They never all intersect, all right? And this one, I can see while planes 1 touches both the other planes, 2 and 3, and while plane 2 does the same thing, it touches 1 and 3. And the same for, they never actually meet at a single point. All 3 kind of never meet at the same point, so that is also 0, all right? The diagram shows 3 intersecting planes down here. How many points lie on all 3 planes? Well, in this one, we can see there is a point right here, right there, where they're all touching together. So that would be a single point. And then we get the final way. When you come down here, they all intersect, and they form this line as 3 planes come together. And how many points? Well, if we got any line, there's going to be an infinite number of points. And I'm going to try to post this video.